Welcome to the ET335 binary counter lab demonstration. Okay, so let's go ahead and grab the components so I can help you build this together. So let's go ahead and grab the ground symbol over there, and let's grab a ground, and let's grab a VCC. Let's open back. We're going to go signal sources, so we're going to need a clock voltage. And we're going to need some gates. So let's go to TTL, and we're going to go to 74 LSIC because they shortchanged us the 112 in all the other ones. The D or the N doesn't make any difference. And it's a pretty clean one. So let's go ahead and grab our Tektronix scope here off the bottom. And I think that's close enough for now. Here in Multisim, I've created a divide by 4 counter. And what I have here is a standard 74LS1112. It is a IC version because that's the only one we have in Multisim. And here I have a clock feeding in, and that's a 5 kilohertz TTL clock. And what we have here is I've tied all the J's and K's high on both ICs. There's 2 of them in here, and all the presets in clear, and I've had to add a ground and VCC, and I tied a oscilloscope to it. Okay, we have our Multisim schematic here. Let's go ahead and fire it up and take a look at the waveform. Okay, let's open up our scope, turn it on. First thing we ought to do is go ahead and spread it out by changing the time scale, and let's dial these all back into 5 volts. That's a good level for a counter. Good, and right there, good. So let's go ahead and use our positioning to move this guy up a little bit. And let's move magenta down. Sorry. Use a position switch. Come on. Good. Now let's go ahead and trigger it so we could actually see it. So let's go to the trigger menu. And we should always trigger off the slowest one. So let's go to channel 3. And let's find our arrow here. There it is. Good. And that's going to be too much for our divide by. So let's go. We need 2 good signals on the bottom. And there we go. And maybe just move it over a little bit. Perfect. And let's go to single sequence. And that's beautiful. Okay. So let's go ahead and go to cursors. And we're going to go to time. And let's move A over. That's our start of our waveform we're interested in. And let's bring the other one in. Alright, and essentially we have the same waveform that we did in the last lab, and we got our count here 0, 1, 2, 3, reset at 4. So this is a divide by 4 count 0 to 3, and that looks good. Here I've modified our last Multisim schematic. And I've added another 74 LS112. This is going to give us our divide by 4. And this additional one is going to give us a divide by 8. So it would go to 4, 8. And if we were to add the other one, it would go to 16. Okay, so again, I pulled everything high that needs to be high. This one remains the same. And I added another scope lead to Q. And I've taken the clock from 2Q over here to the clock over here on the first gate that's inside this IC. So let's fire it up. Okay, so first thing I do is we're going to change our seconds to division so we can see it. And let's go ahead and set everything to 5 volts. And since we're using green, we're going to need to set him to. Good. And actually that looks fairly reasonable. Let's go ahead and move our green all the way to the bottom. And let's move our magenta down. And let's move our blue up. Good. And we need to trigger it so we can see it. So we're going to go to our trigger menu. And again, we need the trigger on the slowest channel. So let's go ahead and go to channel 4. We have the green arrow there. And that's actually looking pretty good. So let's go to single sequence. And that's good. That's our output. Here we have the output of our Tektronix scope in the waveform or divide by 8. And over here we see that we have the trigger arrow and it's triggered off of the slowest channel. Here's the beginning of the trigger, and we use the falling edge on our trigger. So let's go ahead and go through the count here. So there's 0, 0, 0, so we have a 0. We have a 1, 0, 0, which is going to be a 1. We have a 0, 1, 0, which is going to be a 2. Then we have a 1, 1, 0, which is a 3. And then we have a 1, 0, 0, which is a 4. And then we have 1, 0, 1, which is a 5. And then we have a 1, 1, 0, which is a 6. And we have a 1, 1, 1, which is a 7, and it resets at 8. So it's a divide by 8, count 0 to 7.